Welcome back to the Genesis Science Report. When scientists first set their sights on Titan, Saturn's largest moon, they expected to find a world covered in vast ethane oceans, built up over billions of years of time. But when Cassini spacecraft and the Huygens probe finally arrived, what they found, it shocked the entire scientific community. Instead of this thick ethane ocean, they actually found only small lakes, not nearly what secular models had predicted. But even more puzzling, Titan's methane is disappearing so quickly that it should have been long gone by now. Could these findings point to a much younger Titan than scientists claim? Well, joining us to discuss this is David Coppedge, former team lead system administrator for the Cassini mission to Saturn. Now, David Coppedge has been a science journalist in Southern California for almost 25 years. He's a board member of Illustra Media, where he serves as their science consultant. David, it is great to have you back on the program.
Good to be with you again, David.
Now, you were at JPL for 78 Titan flybys when these probes are going around these moons, and you were actually there for when a probe landed on Titan to capture even more data. What was it like to witness those first images that started to come back in 2005?
Oh, that was really exciting. Titan was a prime target of the Cassini mission because it's the largest moon of Saturn. It's the second largest moon in the solar system. In fact, it's even bigger than the planet Mercury. So how can a moon be bigger than a planet? Well, moons go around planets, and planets go around a star like the sun. But it is a major world, and it's the only moon that has a substantial atmosphere. In fact, it's denser than the Earth's atmosphere, about 1.5 times. So if you are on the surface, it'd be like being a scuba diver on the surface. So it's an amazing world.
Yeah, and you're able to see these images coming in. You're sitting around tables with other scientists, amazing engineers who have made these things work. So if you can compare in size moons and planets in the solar system, you mentioned that it is really, really large, but of course we have to remember that its host planet is also very large. So proportionally, we have to take all of that into consideration. But one of Titan's most unique features is that it has this thick atmosphere. It's something that I don't think any other moon has, but what is this atmosphere made out of, and how would it compare to, let's just say, what we're breathing right now?
Well, like Earth, it's mostly nitrogen.
Okay.
Titan's atmosphere is about 95% nitrogen, molecular nitrogen, N2, and about 5% methane, which is a single carbon hydrocarbon, the simplest of the hydrocarbons. And that methane, we've all heard of greenhouse gases, right, with all the talk about climate change. Well, methane is one of the most efficient greenhouse gases, and it's the methane that keeps the nitrogen warm enough to be in the gaseous phase. So without enough methane, here's what would happen, and I heard this from a planetary scientist himself at lunch. He said, without enough methane there, the nitrogen would freeze and it would collapse to the surface catastrophically all at once. I mean, picture that, the whole atmosphere just collapsing down to the surface.
Yeah. Well, that certainly wouldn't be good. But scientists have claimed that this moon has been sitting around for billions of years, and yet there seems to be a problem because Titan's methane, isn't it disappearing a lot faster than they expected, and why would that create a problem?
Yes, this scientist told me that he can only give it like 10 million years, which is a tiny fraction of the assumed age of Titan. And so that's one of three problems that I'm aware of that make Titan appear young. The other one is, like you said, the ethane, the missing ethane. And this remains a problem to this day. There was a paper recently talking about the ethane problem. Now, ethane is a two-carbon hydrocarbon, and what happens is Titan spends about 5% of its time outside of the protective magnetic shield of Saturn. And during those times, it's bombarded by the solar wind. And the solar wind breaks apart the methane molecules and makes these single carbon ions rejoin as two carbon ethane. Now, ethane is a liquid at Titan temperatures, which is like 290 degrees below zero. So you wouldn't want to be down there without a lot of sweaters on or something. But anyway, this ethane should rain down and collect on the surface. And over time, over 4.5 billion years, they calculated that it would add up to like a global ocean, maybe half a kilometer to several kilometers thick of liquid ethane. Well, we landed the Huygens probe, which is like a little flying saucer that the European Space Agency built. And it landed successfully, and it hit the ground with a thud on moist sand made of water ice particles. And a little bit of methane was determined, but the global ocean was not there.
Okay, so that was a surprise because they had suspected that it had been around for long periods of time. But secular scientists now propose that Titan's missing ethane, maybe it's somehow sinking down into the interior of the moon. Was that a possibility, and how does that work?
Yeah, there was a paper recently about that. And to me, it commits the fallacy called special pleading, where the evidence doesn't fit your theory, but you're so married to your theory, you want it to work. And so you invent something to keep the theory alive. And that's exactly what they're doing. They're hiding the ethane out of sight by having it sink into the interior of the moon. But at the same time, they're saying, well, the atmosphere has to be replenished with methane, and so the methane leaks out. So the ethane goes down, the methane comes out, and this is how they keep their precious billions of years.
In other words, they've swept it under the rug, literally, in that model. Now, we know that Titan spends part of its orbit outside of Saturn's magnetic field, which means it's going to be a lot more affected by the solar wind. So, again, wouldn't that strip away the atmosphere over time?
Yes. Like I said, they can give it maybe 30 million years, a tiny fraction of the assumed age of the solar system. But
it's nothing when compared to billions.
Yeah, it's like one 450th of the assumed age of Titan. So this, and one more thing came up just this week. There was another paper in Science about another problem with age, and that is that the orbit of Titan is circularizing over time. It should become circular over billions of years, but it's not circular yet. So they're saying, well, maybe something happened 350 million years ago to kick it out of a circular orbit, and that's how they explain it away. Again, another case of special pleading. So we have three independent observations that Titan is young. And of course, these millions of years they talk about, it's far less than they believe, but it's an upper limit. So it could be far less than that. And so I think they have real problems with the assumption of deep time.
You know, we have had you on the program at other times talking about other moons and the discoveries of the Cassini missions. But when you compare Titan to all of the moons in the solar system, there's kind of this pattern that starts to emerge that seems to be pointing in a particular direction. You've mentioned it a couple of times so far, and that is that the deep time needed by by stellar evolution and other models doesn't seem to be present within our solar system. Is that correct?
Yes, I have about 2 hours worth of material that I've collected on all the planets and moons of the solar system, and they all look young, Pluto being one of the latest. And so, deep time is not a solution to their problems. They want the deep time for Darwinian evolution to take place, you see. But deep time is not a solution. Deep time is the problem. And the evidence does not fit it. So if we follow the evidence where it leads, we've got to conclude that the planets and the moons of the solar system are young. So if Darwinism is ruled out, why not start with a different presupposition, the supposition of intelligent design? And the greatest intelligent designer is the God of Genesis, who tells us what he did. And so to me, that makes a lot more scientific sense. It fits the evidence that we observe. And so it was a great thrill to be at Cassini, at JPL, part of the Cassini program, and to see this evidence come to light.
Oh, I can only imagine. And what you mentioned is that everything seems to fit within a biblical perspective. But we have to remember, the biblical perspective is a historical narrative especially in Genesis there, as it is explaining the origin of the universe. And even though it doesn't go into great scientific detail there, it is history. So we have this history book that is written that tells us about the origin of the universe. And then we go back and we make discoveries, and those discoveries seem to fit this historical record. And it all is pointing us away from speculative ideas like Big Bang cosmology or the chronology of deep time stellar evolution and many of these other things, which you've written extensively on all of these topics at crev.info, Creation Evolution Headlines. And it is quite remarkable what you've been able to do. I really appreciate your research, and I would encourage people to continue to check out your work. David Coppedge, thank you so much for being on the program.
Great to be with you. Thank you.
Absolutely. David, this has been such an eye-opening discussion. I hope that you have learned from this discussion. You know, Titan presents one mystery after another for secular scientists. But you know, the more we look, the more we see evidence that challenges billions of years timeline and points right back to good scientific evidence that is also pointing to our Christian faith. For those who want to dive deeper, check out David's articles at Creation Evolution Headlines and his book, Spacecraft Earth, A Guide for Passengers, co-authored with Dr. Henry Richter. It's available at the Creation Superstore. We are out of time, but don't go anywhere because we're going to be back in just a moment with viewer voices after the break.